Right, key knowledge, let's have a quick look at that. Common design features of fuel cells, including the use of porous electrodes for gaseous reactants to increase cell efficiency. Specific cells not required again. Right? So we see this time and time again in the key knowledge. Specific cells are not required. Right? So it's application, not just rote learning of specific cells. Although some cells do show up from time to time. But that's one of the reasons I showed you that example with Q, because you hadn't seen it before. But we can apply our understanding of galvanic and secondary cells. Comparison of fuel cells and combustion of fuels to supply energy, production of greenhouse gases and applications. So that comes up again. Comparison of fuel cells and galvanic cells with reference to their definitions, functions, design features, energy transformations and energy efficiencies and applications. So qualitative in terms of energy efficiencies, right? So I mentioned that when we were talking about the energy density of all of our different fuels, the other, whatever it was, 2 weeks ago. So that you don't need to know specific values, right? It's about comparison of them. Same thing here. Energy efficiencies is about comparison. Fuel cell, only one specific feature. So we know the feature of secondary cells that allows it to be recharged. The feature of fuel cells that distinguishes it from other cells is that the reactants must be continuously supplied by an external source. So that external source could be storage of, say, hydrogen and oxygen that then feed into the fuel cell, right? So all of our other batteries, are stored within the battery, right? Fuel cells, we're constantly putting it in. If we operate a car, say, for example, on a hydrogen fuel cell, we don't need a stored supply of oxygen. Why? Right, because we can get oxygen from the air. This says it's an alkaline fuel cell. What does that mean? Means it's acidic? No, it's the opposite of acidic. It means it's basic. It means we've got a transfer of hydroxide ions through the membrane or through the, imagine this as salt bridge, right? We've got an anode and cathode. What happens at the anode? Oxidation, right. What happens at the cathode? Reduction, fantastic, there we go. Why do we use porous electrodes? Well, porous increases the surface area, right? If we're increasing the surface area, it means that gases diffuse readily through the electrode. Because what is the purpose of an electrode in a galvanic cell or fuel cell? Yeah. Yes, right. So it's the site or the surface at which the redox reaction occurs. Yeah, where the electron transfer occurs. What are the features that we need in an electrode? It needs to be what? Needs to be electrically conductive. If it's not, then electrons won't transfer. Okay? Hydrogen fuel cells, the only byproduct is water. At the cathode, oxygen plus, right? Oh, realised I called it an alkaline cell, and yet this is an alkaline. So really it should be O2 goes to give OH minus. I need to fix that. Cool. And hydrogen, again, goes to so it will be oxygen plus hydroxide. Am I just right? O2. Anyway, doesn't matter. I'll fix it up later. Cool. So byproduct is water. As we add the two together, right? What's the advantage of water being the byproduct? Right. Technically, water is a greenhouse gas, but it's not nearly as problematic as CO2. No increased atmospheric CO2 and other harmful greenhouse gases. Lots of other different fuel cells. Again, this idea that we don't need to know specific examples. But so we've got alkaline fuel cell, uses potassium hydroxide as the electrolyte. So we can see here, right, hydrogen plus hydroxide gives us water and electrons. At the cathode, oxygen plus water gives us, plus electrons gives us hydroxide. So that's actually what I should have had in the previous example. So I'll make sure to fix that up. Notice like we've got fairly high operating temperatures, right? Even though they're already gases at room temperature, higher operating temperatures means the rate of reaction is higher. And they're much, much more efficient, right? Fuel cells are much more efficient than combustion engines. Far more efficient. Why? Can you have a guess as to why fuel cells might be more efficient? Yeah, what's the main source of error when we were doing our pracs? Heat loss to the environment. Fuel cells, any heat loss to the environment? No. Well, they might have a bit of heat, right? It is a exothermic reaction, but the difference is we've got direct conversion of chemical potential energy into electrical energy, right? So much less energy loss to the environment. Again, more examples, blah, 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 etc. This is all about hydrogen cells. What do you mean it's unavailable? Okay, all right, so it's unavailable. Here we go. I had a couple of activities I'll get you to do, and we'll come back to that. Comparing fuel cells with combustion, comparing fuel cells with galvanic cells. We're going to draw up. Don't worry about this too much. Just ignore that. We'll come back to that. Okay, type of breathalyzer instrument used by police. Measurement of the concentration of alcohol in a driver's breath is a fuel cell. Acidic electrolyte is used, which means we can use what? Co-hands, thank you. Ethanol is oxidized to ethanoic acid at one. Oxygen from the air is converted to water at the other. So this information gives us the starting and ending points of our cathode and our anode reactions. Here is our overall equation. So we've got that goes to this and that goes to that. Write the equation for the half reaction at the anode. What occurs at the anode? Oxidation. It already tells us ethanol oxidized to ethanoic acid. There you go, write that down. Ethanol, C2H5OH, right, goes to give C2, what did I say, CH3COOH. CH3 COOH. Key, carbon, two carbons. Right, oxygens, one oxygen, two oxygens. I need what? One water, H2O. 5, 6, 7, 8, 4 on this side. What's the difference? 4H plus, and I need that here. 0, 0, 0 plus 4, therefore 4 electrons. Put my states in: aqueous, liquid, aqueous, aqueous. Fantastic. Done. Motorist who's consumed alcohol. Actually, ignore part B, right? Nature of the electrode in the cell is essential to the effective operation of the breathalyzer. State 2 important functions that the electrode must perform. Thoughts? Stay in contact? No, it's not rechargeable. It's a fuel cell. Yeah, fuel cells we do need to continuously supply, right, the reactants. That's not to do with the electrodes. Let's apply, think about your answer that answers the question. We just talked about electrodes. What must an electrode have or be able to do?
Supply electrodes.
Well, yeah, right. So one function of an electrode is to conduct electricity. Yeah. And the other function, right, to be the site at which electrons are transferred. Here we go. Right, 1 mark given. If the correct chemicals were used, but the equation was unbalanced. quite a few students gave the cathode reaction and would have got nothing. Only 30% got 2 marks, average 0.8. 59% of students got nothing. 8B. Oh, yeah, I said ignore part B. Right, so 32% got 2 marks. Any two of carry current, catalyze the electrode reactions. Porous, we mentioned that. They're unreactive, right? I didn't mention that, but they are. We want unreactive electrodes when using gaseous components or when using two aqueous components that transfer, yeah? If the reaction is in basic conditions, is not technically part of the course, but we should either be able to deduce what it is from the full equation, or we will be given the half equations.
Okay, great.
All right. Another question. What did I say? 32% got 2 marks there. Average was 1. So most students could say one thing. Internet site reporting latest developments in fuel cell technology describes a cell that uses solid ceramic material as the electrolyte, hydrogen gas and oxygen gas as the reactants. Key features of this cell are: water is the only product. Ceramic material allows the movement of oxide ions. Reaction at the anode is H2 plus O2 minus goes to give H2O plus 2E minus. Operation at very high temperatures of over 1,000 degrees means that precious metal catalysts are not required. Representation of the cell is below. Here we go. What distinguishes a fuel cell from a galvanic cell such as a dry cell or lead acid battery? Constant supply of reactants. Right, both of you. Excellent. Part B. On the diagram, circles A and B indicate the polarity of the cathode and the anode. It tells us what the cathode is, tells us what the anode is. Right. Not a trick question. Correct. Positive and negative, right? Fuel cell, think galvanic. Don't recharge, yeah? Show by using an arrow the direction of electron flow in the external circuit. No! That way. Not left to right. It is, yeah, right? Right, from anode to cathode via the external circuit. Run an equation for each of the following reactions. You're not required to show states in these two equations. Overall cell reaction, what does it say? I've got hydrogen gas plus oxygen gas gives us what? Water. Right, there's our equation for the overall. That's nice and easy. I would want to balance that. 2 there, 2 there.
Wasn't there oxide ions?
Yes, but this is overall. Now, reaction at the cathode. Cathode is says what the anode reaction is. Right, we've got the anode reaction. We want the cathode reaction, which involves oxygen, and we want the product to be oxide. Yeah? Does that make sense? Right, 2 of them, so I need 2 there. 2 times 2 is 4, 4 electrons, done. Yes, it's not going to simply be straight off your electrochemical series. Ignore part D. We'll get to that later. Another question, I don't know if you can read that very well. Cross-section of a small zinc air button cell. Actually, I should really put this in the other equation because this isn't a fuel cell. Right, so I'm going to ignore that and we'll come back. I'll put that one example back in. Okay, here we go. So here's another battery. This relates to our previous topic. Zinc acts as the anode. It forms a powder dispersed in a gel, jelly-like substance, that also contains potassium hydroxide. The cathode consists of a carbon disc. Oxygen enters the cell via a porous Teflon membrane. Membrane also prevents any chemicals from leaking out. Following reaction takes place as the cell discharges. Discharge, think galvanic.